It's a bird. It's a plane. No, it's someone with curls. It's Math Girl. Okay, today we're going to be doing trig ratios. Ratios is a fancy word for fraction. So these are trigonometry ratios. So you have the acronym of Sohcahtoa. What does that help us remind us of? That sine equals opposite over hypotenuse, cosine adjacent over hypotenuse, tangent equals opposite over adjacent. And I have all the three trig ratios right here. Sine, cosine, tangent. So sine opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. Okay, so looking at 1C, we're looking at problems 13 through 18. You have this right triangle again, or not again, but sine, cosine, and tangent trig ratios can only be used with right triangles. You have to have a right triangle in order to use trig ratios. So in 13 through 15, first we're trying to find sine, cosine, and tangent of theta. So it's like you have a little man standing here at theta. It's because the opposites and adjacent sides are always relative to where you're standing. The hypotenuse will always be across from the 90-degree angle. Always, always. So the hypotenuse never changes. This is the hypotenuse. Your opposite side and your adjacent side will always be relative to where you're standing. So first thing we have is sine theta. Sine is opposite over hypotenuse. If you're standing right here, the side, because you're going to be standing at theta, so if you're standing at theta, the side opposite of you is the 13.6 and hypotenuse is 15. The issue with this fraction is I have a decimal in a fraction. A decimal is just another way to write a fraction, so it's usually not the best format to have a decimal within a fraction. Okay, so even though this is it's not wrong, it's not the best format. So anytime you have decimals in your triangles, I would get rid of your decimals. Okay, so how do you get rid of decimals? You look at the most decimal places. This has 1, this has none. Since the largest decimal place is 1, in order to get rid of my decimal, one decimal place multiplied by a number that's a multiple of 10, and so one decimal place, 1 0, which is 10. 10 has 1 0. So if you multiply that by 10, your decimal place will move over 1 to the right. But if you're going to multiply that by 10, you have to multiply everything by 10. And so this one will also move your decimal place over to the right. So our new numbers will end up being 136 for that side, 64 for this side, and 150 for that side. So we're going to use the numbers in blue that don't have the decimals in them to do our sine, cosine, and tangent. So sine, opposite over hypotenuse. If I'm standing there at theta, the side opposite of me, 136, and then hypotenuse, 150. Okay, those both can be reduced by 2 for sure, and I think that might be the most that we can reduce them by. So always reduce if you can. So it would be 68 over 75. That would be sine theta. Sine theta is 68 over 75. Now let's do cosine theta. Standing here at theta still, cosine is adjacent over hypotenuse. If I'm standing here at theta, the side adjacent to me is 64. Hypotenuse is always the same, so that would be 150. We can reduce those both by 2. So that would be 32 over 75, and that can't reduce any more than that. So cosine theta would be 32 over 75. Tangent theta, opposite over adjacent. So if I'm standing there at theta, the side opposite of me, 136. The side adjacent to me, or next to where I'm standing, 64. And I believe those can both be reduced, the largest number by 8. That would be 17 over 8. Let me double check. Yeah, reducing them both by 8. So tangent theta would be 17 over 8. Okay. Now for 16 through 18, we're wanting to do sine, cosine, and tangent of alpha. So Now I am no longer standing at theta, I would be standing at alpha. So everything is relative to where you're standing. So standing over at alpha, sine is still opposite over hypotenuse, but now I'm standing at alpha. So standing at alpha, the side opposite of me would be 64, and hypotenuse doesn't ever change, 150. So reducing that would be 32 over 75. Now I want cosine of alpha, so if I'm standing here at cosine, cosine is adjacent over hypotenuse. So standing here, the side adjacent to me is 136, and hypotenuse is 150, and so that will reduce to 68 over 75. Standing at alpha, tangent is still opposite over adjacent. So if I'm standing at alpha, then opposite of me, 64, and then adjacent next to me at alpha is 136, and that will reducing them both by 8 over 17. Okay, the one thing that I want you to notice is that sine theta, 68 over 75, is the same as cosine alpha, 68 over 75. A few lessons down the road, we will learn that these are actually called cofunctions. They are complementary because these two angles have to be complementary because they add up to 90 degrees. This is 90 degrees. These two have to be add to 90, and two angles that add to 90 is called a complementary angle. And so these are called complementary functions, but they shorten it to call them cofunctions. The same is true. Cosine theta here is the same as sine alpha of the other one. So cosine theta is the same as sine of the other one. And then if you look at the tangents, they're going to end up being reciprocals of each other. Alright, let's go to page 1A. In that problem, the main thing to remind everyone is to get rid of your decimals. Don't have a decimal in a fraction. So now looking at page 1A, same thing, 13 through 18. We're still going to be doing sine, cosine, and tangent of alpha and theta. Again, this Greek letter alpha, that Greek letter is theta. This problem is a reminder to get rid of radicals in the denominator. Anytime you have radicals, always look to see, can you simplify the radical, or do you need to get rid of the radical in the denominator? Square root of 130 does not simplify any more than that. So sine theta, need to be sure and look where theta and alpha are at. They won't always have them drawn in the same spot. So here, first off, I'm standing at theta. Sine theta, sine is opposite over hypotenuse. So if I'm standing here at theta, the side opposite of me is 7. And the hypotenuse, always across from the 90-degree angle, square root of 130. You need to get rid of the radicals in the denominator. How do you do that? You multiply it by itself. So we multiply the denominator by square root of 130, which means we also have to multiply the numerator by square root of 130. So in our numerator, 7 times square root of 130 is just 7 square root of 130. The square root of 130 times the square root of 130, anytime you multiply a radical to itself, it's like the radical cancels. Because truly what that will turn out to be is 130 times 130 would be the square root of 16,900, and the square root of 16,900 is just 130. So whenever you multiply a radical to itself, the radicals cancel and you get only the number underneath the radical. And then always look to see if these whole numbers will reduce. 7 over 130 to see if that will reduce. That won't reduce, so this would be your final answer. That would be sine theta is 7 square root of 130 over 130. Now let's do cosine theta. Cosine is adjacent over hypotenuse. If you're standing here at theta, then the side adjacent to you, 9, over the hypotenuse, which is square root of 130. Get rid of the radical in the denominator. So you have to multiply the numerator and the denominator by the square root of 130, which makes it 9 square root of 130 all over 130, and then I don't believe that 9 and then 130 will reduce. Nope, I was going to see if they would both reduce by 3, but they won't. So that would be your final answer for cosine theta. Tangent theta, opposite over adjacent. If you're standing here at theta, the side opposite of you, 7. The side adjacent to you, 9. And you can't reduce that fraction any more than that. Okay, now we're going to do sine, cosine, and tangent of alpha, which means you are now standing where alpha is, not at theta. Remember, it's all relative to where you're standing. Sine is still opposite over hypotenuse. The definition of sine, cosine, and tangent does not change. It just depends on where you're standing. So if I'm standing at alpha, I want the side opposite of me. The side opposite of me is the 9. And then the hypotenuse is still the square root of 130. Getting rid of the radical in the denominator, multiply it by itself, and that would equal 9 square root of 130 all over 130. Remember, sine of alpha should be the cosine of the other angle. Those should match. Cosine of alpha, this should match the sine of the other angle, but we're still going to go through the motions. Cosine is adjacent over hypotenuse. Standing here at alpha, the side adjacent to me, 7. Hypotenuse, square root of 130. Get rid of the radical in the denominator. 7 square root of 130 all over 130. That doesn't reduce. Tangent of alpha. Tangent is opposite over adjacent. Standing here at alpha, the side opposite of me, 9. The side adjacent to me, 7. And that doesn't reduce.